HellVolhardZelinsky reaction. Carboxylic acid containing alpha hydrogen is going to convert into alpha halocarboxylic acid. This reaction called alpha halogenation, in which we are going to kick off this hydrogen and will add halogen at this site. And for that we need a halogen, phosphorus halide, and water at the end. Now let's see the mechanism. In the first step of mechanism, this oxygen is going to attack on the phosphorus and will have a new bond with phosphorus. At the same time, one of the halogen is going to leave for stability of phosphorus and will have px2. One halogen is eliminated, and that is this one. Oxygen is being positive with 3 valency. Further, that released halogen from this is going to attack on this carbotyl carbon of this. At the same time, this carbon is being unstable with 5 valency, and to stabilize that, this oxygen is going to accommodate this pi bond in the form of lone pair and will have O minus R1 R2 H, new bond with that halogen, and OH PX2, where one oxygen is negative and one is positive. We have added this halogen to this carbon. Again this oxygen is will again this oxygen will try to be stable, and for that it will make a double bond again. And when that double bond forms again this carbon is being unstable. So for the stability, one of the group from this carbon has to leave, either this halogen or this hole. Two bond can break, either this one or this one. Now if this halogen is going to leave again, we are not going anywhere. Again we'll have that, and again halogen will attack. So this reaction is reversible. This reaction is not going anywhere. To drive this reaction forward, now this carbon oxygen bond is going to break instead of this halogen bond. Yes, halogen is good leaving group, but to drive this reaction forward, that oxygen is going to break that bond. And this bond, now this bond is going to shift between oxygen and phosphorus. So again one of the halogen is going to leave, and that halogen will have a proton from this oxygen for a stability of this oxygen. And now we'll have multiple components, which are this double bond R1 R2 H and X, plus this OPX, and this halogen has abstracted that proton, so we'll have HX as well. Again this oxygen will form double bond again, so this oxygen carbon bond is going to break, and this oxygen will shift this bond between this oxygen and phosphorus. So again phosphorus will have 1 2 3 4 valency, so one of the halogen is going to leave, and that halogen will get that proton from oxygen and will form this and this and this. Now next, this oxygen is going to have the proton from HX that just formed, and will have bond with that hydrogen and will form this. At the same time, this halogen from HX now is going to abstract this proton. So oxygen has taken that proton and halogen is going to get this proton. So this carbon hydrogen bond is going to shift between carbon and carbon, and again carbon will be unstable with 5 valency, so this carbon will accommodate this bond in the form of lone pair. So oxygen is stable as well as this carbon is stable, and we have made double bond. Enol is generated. You can see this is in and alcohol all, so the enol formation take place. Further we have one more reagent which is X2. Now this nucleophilic alpha site is going to use this pi bond and will attack on this halogen, one of the halogen from X2, and will have new bond with that halogen. So now that halogen is going to add it to the alpha position, that what we want, and this carbon is being unstable again. So again that oxygen is going to make a double bond and will be positive, and that another halogen is going to grab that proton and again will form HX. So this oxygen is stable as well, and we have this compound right now. Further we just need OH at this place to form alpha halo acid, and to do that we are going to perform a hydrolysis, and for that water is there. Now that water is going to attack on the electrophilic carbon, and that water is going to add it over here, and to stabilize this carbon, this oxygen will get that pi bond in the form of lone pair and will form again oxyanion. This oxygen is positive and this one is negative, and so now this oxygen is going to make a double bond again. At this time this halogen is going to leave, and when this halogen is going to leave, it will leave with one of the proton from that oxygen and will form HX. So now oxygen is stable as well as this oxygen is stable, and that halogen is gone, and this is our final product, which is alpha halocarboxylic acid. Why the step called hydrolysis? Because H from water is going with that halogen, and that OH is going with this carbon and going to break that structure. Lysis, that means breakdown of that structure, and addition of water. One H is going with halogen and that OH is going with that carbon, and this is how there is a formation of alpha halo acid.